Hello friends, welcome to the session of the electronics. Let us see the moving target indicator. If radar is used for detecting a movable target, means the target is moved from one place to the another place, such types of the target is known as the movable target. Then radar should receive only echo signal which is coming from the movable target, and this echo signal is only desired. But practically what's happened? The radar receives the echo signal due to the stationary object in addition with the echo signal which is coming from the moving target. Means radar can receive both types of the signals. Both means the signal from the stationary object and the signal from the moving object or the target. These two types of the signal is received by the receiver. But here expected is only the signal coming from the movable target. The echo signal due to the stationary object which are due to the land or sea, which is called as the flutters, means the signal coming from the stationary objects, that signal is known as the flutter signal, and these are the unwanted signals. Therefore, we have to choose the radar in such a way that it can accept only the signal coming from the movable target and not from the stationary target or the object. Therefore, for this purpose, the in the radar, the Doppler principle is used. Means the Doppler effect. The principle of Doppler effect is used, and that can be distinguished between the stationary or non-stationary object. Means the Doppler effect principle can differentiate the two signals, which one comes from the stationary object or which one comes from the movable target. Okay, so this type of the radar is known as the moving target indicator radar, or it is simply shortly in the short form it is denoted by MTI radar. So let us see the moving target indicator radar. First of all, let us see the Doppler effect. According to the Doppler effect, the frequency of received signal will increases if the target is moving towards the direction of the radar. If the target is coming towards the radar, then its frequency is increases. But when the frequency of reduced signal which is coming from the target and which is moving away from the radar, then that frequency is decreases. Okay, so this is the difference between the two types of the signal. If the signal of the radar is signal of the target which are moving towards the radar, then its frequency is increases. Okay, and if the target is moved away from the radar, then that frequency is decreases. Okay, so this is the Doppler effect. Now let us see the types of moving target indicator radar. There are the two types of the MTI radars, which is based on the transmitter that has been used in the radar system, and therefore there are the two types of the radar, that is the MTI radar. First one is the MTI radar with power amplifier transmitter. In this radar, the power amplifier is used in the transmitter. Therefore, its name is power amplifier transmitter. And the second type of the radar is the MTI radar with power oscillator transmitter. Means instead of using the power amplifier, the power oscillator is used in this transmitter. So this is the second type of the MTI radar. Now let us discuss MTI radar one by one. First of all, moving target indicator radar with power amplifier transmitter. The MTI radar uses single antenna for both transmission and reception of the signal with the help of duplexer. Same antenna is used for both functions, that is the transmission and the reception, and that can be achieved with the help of duplexer. And the block diagram of MTI radar with power amplifier transmitter is like this. This is the MTI radar with power amplifier, and in this radar section, this is the transmitter section. Okay, and in this transmitter section, this is the power amplifier. Okay, and this is the receiver section, and the receiver section for both radar is the same. But here for the MTI radar with power amplifier, here the power amplifier is used. In another type, the oscillator is used, power oscillator is used. This is the only difference in the radars. So the pulse modulator, this is the pulse modulator, and the function of pulse modulator is to produce the pulses. That is, the modulated signal is produced by this pulse modulator, and which is also be known as the power supply for the power amplifier. Therefore, the pulses, high energy pulses produced by this pulse modulator is applied to the power amplifier, and this power amplifier amplify the power level of pulse modulated signals. Okay, then the local oscillator, this is the local oscillator, and this is simply one oscillator, and this local oscillator produces the frequency, and that frequency produced by this local oscillator is provided to the mixer 1, and that also provided to the mixer 2. Means the output of local oscillator is applied to both mixer 1 and mixer 2. Similarly, here there is the another oscillator, and that oscillator is known as the coherent oscillator, and this coherent oscillator is also produce the intermediate frequency, and that frequency is FC. Actually, this frequency is known as the reference frequency, or this signal is known as the signal produced by the coherent oscillator is known as the reference signal, and the output of this coherent oscillator is connected to the mixer 1 and also phase detector. For both phase detector and mixer 1, for both section, the coherent oscillator feed its frequency. Okay, then the mixer 1, function of mixer 1, and this mixer 1 produce either, actually the function of mixer is to mix the two frequencies and produce the difference in the frequencies. So this mixer 1 produce the difference of frequency that are applied to the mixer 1. Here the two frequencies are applied to the mixer 1. One frequency from local oscillator, another frequency from coherent oscillator. Therefore, this mixer 1 produce the difference of these two frequencies, that is the Fi minus Fc, and it also produces the sum of the two frequencies. Output of the mixer contains Fc plus Fi, Fc minus Fi. Fi, and the Fc plus Fi is provided to the power amplifier. Okay, then the duplexer, and here this is the duplexer, and actually duplexer is nothing but one switch which can connect the transmitter to the antenna, similarly the receiver to the antenna. Okay, when this power amplifier is ready to transmit the signal, then this duplexer is connected to this transmitter, as well as the signal transmitted by the power amplifier is fed to the antenna. Then automatically this duplexer disconnect from the transmitter and automatically connected to the receiver. Okay, therefore here when this power amplifier transmits the signal, and that signal is equal to Fc plus Fi. Okay, and such types of the signal is transmitted by this antenna. Okay, and immediately this duplexer is connected to the receiver section, and this antenna received the signal from the target, that is known as the echo signal, and that echo signal having the frequency Fi plus Fc plus or minus Fp. Okay, when the duplexer is connected to the antenna, then uh, duplexer connects the receiver sections to the antenna. Then such types of the signal are issued by the duplexer, that having the frequency Fi plus Fc plus or minus Fp, and that signal is provided to the mixer 2. Okay, here the mixer 2 can produce either sum or the difference of the frequency that is applied to the mixer. Here the two types of the frequency applied to this mixer. One is coming from the duplexer, means coming from the antenna, and another frequency from the local oscillator. Therefore, the output of this mixer 2 having the frequency Fi plus Fc plus minus Fd and Fi, and that is applied to the mixer 2, and which is used for producing the output having the frequency Fc plus minus Fd, and that is applied to the IF amplifier. So this is the IF amplifier, and Fc plus minus Fd is nothing but the difference of the two frequencies, and that frequency is known as the intermediate frequency, and this intermediate frequency amplified by this amplifier, that is known as the IF amplifier. Okay, and the IF amplifier having the frequency Fc plus Fd, and this amplified signal is applied to the phase detector. This is the phase detector. Okay, and this phase detector is used to produce the output signal having the frequency Fd. Fd is the frequency coming from the echo, which is coming from the target. Okay, this output signal having the frequency of Fd from the applied of the two input signal, which having the frequency Fc plus Fd and Fc. The output of the phase detector can be connected to the delay line canceller. So the output of this phase detector is provided to the delay line canceller. So this is the working of MTI radar with power amplifier. Now let us see the MTI radar with power oscillator transmitter, and this is the figure of the power oscillator transmitter. In this case, transmitter section, instead of using the power amplifier, here we are using the oscillator, and this is the magnetron oscillator, and the working of both radar is same. So this is the MTI radar with power oscillator transmitter, and here magnetron oscillator is used. Okay, this is the block diagram of the power oscillator transmitter, and this block diagram with power oscillator transmitter, as this uh, working of both are the same. Here the receiver section is same, only the transmitter section. In the transmitter section, the change is in the, instead of amplifier, oscillator is used. Okay, so the output of magnetron oscillator and output of local oscillator is connected or feed to the mixer 1, and this will further produce the intermediate frequency signal, okay, and IF signal, the phase of which is directly related to phase of the transmitted signal. Here this is the IF amplifier. Okay, the output of mixer 1 is applied to the coherent oscillator. Therefore, the phase of coherent oscillator output will be locked to the phase of IF signal. This means the phase of coherent oscillator output also directly related to the phase of transmitted signal. So, the output of coherent oscillator can be used as a reference signal for comparing the received echo with the signal corresponding to the transmitted signal using the phase detector. Here, this phase detector detects which signal is transmitted by the transmitter and the signal coming from the echo. Okay, and the phase difference between these two signals is detected by this phase detector. In this way, this circuit will work. That is the MTI radar with power oscillator transmitter. Okay, thank you for watching this video.